Fourth Criteo meetup. I've done one in Paris at headquarters and two here. And I did one partnered with ThoughtWorks was my last one. I'm going to talk about Aerospike. How many people here know about Aerospike? I love you people. Look at you. I must be doing my job because the first one here, there were 0 people who even knew what Aerospike was. So I'm going to, before I get started, what do you got? Why do you guys know about Aerospike? I know why you know about Aerospike. Why do you guys know about Aerospike? Oh, look at you. Excellent. Excellent.
We did in Criteo and actually in also.
Like, are we tracking all this? Because this is part of my OKRs, getting people to know. Look, I'm not a database guy. And I think I've said this here before. I'm an application developer guy who uses databases for storing stuff, right? Because we just have to, right? I've been at Aerospike 2.5 years. I'm the field CTO at Aerospike, as well as I run all field technical services, which means all the sales engineers and professional services people around the globe fall in my org, and where they have issues, it all gets rolled up to me. So I'm pretty technical as well because I'm their safety net. I'm there supporting them as they're out talking to our customers. Aerospike is, and I'm going to have a couple of slides, but just to give you guys an idea for those of you who have not used it, I'm going to talk about a couple of things that are going to seem crazy. One of the things I'm going to talk about is our latency. We have sub-millisecond latency. Just to give you an idea what that is, how fast do you think a blink of an eye is? It's 100 milliseconds. So you'd have to do 100 blinks, right? You'd have to be able to do 1/100th of a blink to be as fast as Aerospike. Just to give you an idea. The other thing I'm going to talk about today, because we're talking about Aerospike and this incredible database, is the other thing I'm very passionate about, which is Kubernetes. I fell in love, and I am a Kubernetes fanboy. I fell in love with Kubernetes about 8-9 years ago. At my previous job, I was with a company called Enterprise DB that did a lot of Postgres work, enterprise Postgres work. I built the first Kubernetes operator at EDB, and I've been critical in pushing our Kubernetes operator at Aerospike into what I think is probably one of our best products. With the help of the team at Criteo, and I'm going to talk about some of the things that you guys have done, we've actually have something that allows us to achieve everything we can achieve both in cloud and on bare metal and on VMs in an actual Kubernetes environment, which when you think about it for a stateful database is a kind of a crazy thought, because Kubernetes is not supposed to be for stateful databases, right? Everything you read, the only person another man crush, Martin Fowler, the only person who's ever said, you might be able to use this for stateful databases is that guy, right? But everybody else says, no, you can't run Oracle in it. MySQL runs MemMap. Postgres is okay, but really doesn't scale. But Aerospike really works well in Kubernetes. So I'm going to try to mix those two things today. I'm going to try to get it done in 30 minutes. That's usually not enough time, but we'll figure it out. Is this working? Let's see if this, there we go. So just a couple of design principles. Aerospike is all about strongly consistent transactions. What does that mean? We actually have cap theorem strong consistency, meaning that we will not return success to a client app if you've got strong consistent mode on till the replicas are actually written, guaranteeing data integrity. Another one is we are actually truly a geo-distributed active database. Again, what does that mean? You can have a cluster in multiple regions. 3 regions, 5 regions. Insert into any one of those and insert into another one of those, right? And we will figure out and we will conflict resolve and make it all work. Built into the core of our database. There are very few things Postgres can't do active-active. They like to tell you, but they can't. Cockroach tries, where's my essay, right? They can somewhat do it, but we are a truly active-active database. In that time frame, right, we say network speed plus 1 millisecond, network speed plus 2 milliseconds. So if your network is at 40 milliseconds, at 42 milliseconds between your replicas, you're strongly consistent. We are optimized for modern system architectures, right? Postgres is 45 years old now, right? Oracle pushing on 50, if not 50. We are built around modern CPUs, things like NUMA pinning, which I hope none of you will ever have to understand, because right? We have something that is patented to us, which is hybrid memory architecture, which is, and this sounds very common, indexes in memory and storage on flash. And Nicolas, our SC for this region based out of France, put it very well. It is like building pointers to physical storage blocks. What does that mean? When you index data in memory, we know exactly where on the disk it is, so it's 1 IO to pull it out. And we also don't need file systems. Who needs stinking file systems? We write directly to NVMe raw storage. The only other database that does that is Oracle, and they spent $1 billion building ASM. I wish we had $1 billion. You guys can help us get there. But we built it, it's patented to us, and it's part of our secret sauce. And we are heavy network dependent. We are truly a distributed database. And then when we talk about massive parallelism, the thing is written in C. It's been written in C from day one, and it is all about concurrency, running parallel threads, running through queues. Our engineers are focused on achieving performance through parallelism. So as our CPUs get better, as we have more cores, more parallel threads, more hyper-threading into our CPUs, we're only going to get faster. Wrong way. This is going to be the hardest thing today, this button. Just to give you kind of an idea, we run on 3 tiers. We run on all flash, literally indexes and data on flash. Okay? Why can we do that? Because of the way we store our data, and because when we do write and read from flash, we're reading raw blocks. We're not going through file systems. We're not going through fsyncs. We're not waiting for the kernel to give us permission. We are going right to storage. So we can put, I like to use, how many people here use Cassandra? Good, don't. We can put Cassandra, a petabyte of data on Cassandra is about 250 nodes, okay? We can do it in about 40 because of this, because we're storing what Cassandra keeps in memory on storage, on NVMEs. We use NVMEs like DRAM with close to DRAM speeds. So large petabyte scale, put it all in all flash. You want efficiency and better sales term, TCO, HMA. If you need microsecond access, we also run in all in memory configurations, okay? So why is this important? Because in the same cluster, say you have 10 terabytes, 20 terabytes, 300 terabytes of data, we segregate the data into what we call namespaces, and any namespace can have any one of these configurations. So in the same cluster, you can run in memory, all flash, or HMA. Only ones who do that. And then we've got some cheat codes. So we've got AWS building instances for us. So when you look at I4Is, I4Gs, they were built for Aerospike. Z instances on GCP, same type of thing. They are building dense nodes for Aerospike because some of their bigger clients use us for their real-time performance data. And if you think about it, if you were to put a 250 I4Is for Cassandra, it's like a $4 million investment. For us, it's 40 nodes. You're running like 400 grand a year. So just to give you kind of context into why we kind of win in this space. All right, massive parallel architecture, not much of this. We run everything in parallel, okay? Awesome, but it also can lead to race conditions, and our engineers spend a lot of time minimizing that. And some of the things, for example, we are now building things like vector and graph, and we pulled back the release of vector because it's not Aerospike. It's not performing the way we want it to. Our brand is built on performance and scale, so anything we put out has to be built on performance and scale. And then lastly, why Kubernetes? Orchestration and automation and governance and compliance makes it super easy to deploy things, to make sure you're following security compliances, to lock it down, to keep it away from people who might want to misbehave with either the data or your processes. How many people here use Kubernetes? Oh, look at you guys. Kubernetes and databases, right? This is actually true. If you read articles, right, no one says, put your database on Kubernetes. It's transient, it's ephemeral. Stuff falls apart. Nodes, pods die. Your data is gone. You overwrite disks, right? We have solved this problem. We've spent the last 2.5 years getting there, making this problem go away for customers. Our Aerospike deployments were all VM and bare metals, right? It's hard to size VMs and bare metal. Why? Because you leave a lot of resources hanging out, right? You leave a lot of cores unused, or for us, for example, we are memory and network intensive, but we're not CPU intensive. So when you've got 40 nodes of a petabyte of data, a lot of CPUs are just kind of hanging out. So these are some of the things that our AKO, Aerospike Kubernetes Operator, solves, okay? These problems are not just Aerospike problems. Oracle, if you run Oracle, same problem. If you run Cassandra, same problem. Everybody has this wasteful resources. What I used to say, right? Kubernetes is a CFO's godsend. Why? Because now they bought all this hardware, and now they have an orchestration platform that can actually make use of every CPU and every memory stick in that piece of hardware. And that's what Kubernetes is geared towards. Put it out there and utilize your resources as efficiently as possible, right? This is why I fell in love with Kubernetes 10 years ago, because I was going around building people solutions, and we'd spend a year building them, and they say, okay, let's put them into production. Where's the security? How are you deploying it? How are you doing upgrades? And I'm like, wait, that's not my problem. That's your problem. You're the ops guy, I'm the dev guy, right? How many people here have actually heard that, right? It's true. I'm the dev guy. I don't want to deal with upgrades. I'm not going to upgrade my app. if someone tells me there's a bug, I'll fix it and then, you know, CI/CD the thing back through and the database, who cares, right? It basically allows us to remove all that noise and eases the DevOps, truly eases the DevOps process if you have automation built in. Criteo, and why I'm glad I'm giving this talk here, has this down. Their DevOps teams are the best I've seen because the automation is crazy. I mean, crazy to the point of they run something like, hold on, 600 odd clusters, right? All in Kubernetes. And they can upgrade them with like no manual intervention. They're like, send that CR, boom, clusters upgrade. And they're following financial regulations, nodes get rehydrated, all that is done in a fully automated fashion, all because they decided early on that Kubernetes was their platform. And they're using a database, and they're using our database. They helped us expand and evolve our Kubernetes operator to handle large scale clusters, right? So like I gave my first Kubernetes talk at the Criteo headquarters about storage, and it was storage. I didn't get a chance to tote, and I learned about what you guys were doing from an automation perspective, and it is crazy. Like, blew my mind. I sat there with your VPs going, hold on, how are you doing that? And they're like, no, this is the way we do this. And I was like, oh, right? So this is why I think Kubernetes is the answer for stateful databases, for well-behaved stateful databases. So we'll give you an idea. Our one Kubernetes operator in a Kubernetes cluster, let's say 30 nodes of Kubernetes. And I'm going to try to be very specific about the language because they use nodes, we use nodes. They talk about namespaces, Aerospike talks about namespaces. So if you have a 30 nodes Kubernetes cluster with many pods of Aerospike in them, okay, and many Aerospike clusters in them, within one Aerospike cluster, you can do the same thing you can do on bare metal and VMs. In-memory clusters, in-memory with, I don't like the word NAS, that's a bad word for me. It actually triggers me because I think network attached storage is bad. Fiber attached is where the world is. In-memory with persistence, meaning that we can have all our data in memory, and the Aerospike cluster, the Aerospike database, will decide when to flush to disk. And you can actually give it commands to do partial flushes. But when to flush to disk, why is this important? Because when a Kubernetes pod or node dies and an Aerospike pod dies, and you have, I don't know, let's say a terabyte of data, you can restore that pod right from the persisted data, right from the NAS or fiber attached storage, right back in and pick up right where you left off. In the meantime, for those of you who've heard me talk about the kind of the innards of Aerospike, when you lose a pod in Aerospike, Aerospike says, oh, I used to have 10, I now have 9. I need to rebalance my cluster. I need to move my data around. I need to promote someone to be master. That is more secret sauce because we do that automatically. No one has to tell us to rebalance clusters. No one has to tell us to migrate data from one node to another. It all just happens. The cluster says, hey, I need a new master because I just lost that pod, and starts moving data around to maintain its balance. And the moment that a new pod comes back up, it says, oh, I'm back to 10, let me rebalance. And it does it in a smart fashion so that it doesn't overwhelm your networks. It doesn't overwhelm your storage. And it maintains performance. So that 1 millisecond I was talking about, maybe goes to 1.25 while it's migrating, but then it restabilizes at 1. So all that in the core of the database we've spent 14 years perfecting this. And the data gets, by default today, the data is perfectly balanced across all our Aerospike nodes. Okay, go ahead.
How long can it take to rebalance?
Depends on how much, so great question, Aerospike user. So depending on how big your data partitions are. So if you've got, so we can have up to 4K partitions, 4096 partitions. If your partition is holding, I don't know, half a terabyte of data, depending on your network speed, that gets moved around pretty quickly, right? One partition can have up to 2 terabytes of data. So if you're moving around 2 terabytes of data, how long does it take, how fast is your network to move around 2 terabytes of data? Now, keep in mind, the reason we can maintain performance and scale is because we don't let that go. We don't destroy that until we guarantee that it's been copied successfully to its new location. Okay? So we maintain that data. Data integrity is critical for us as we talk about Aerospike. And we do all this in Kubernetes. Think about it. Nobody looking at it. If you're running Kubernetes today, like the only thing you have is your observation and monitoring. It is hard to go in and start sending command line commands to a database in Kubernetes. It's not straightforward. We do it all through the core database. The core data, every node in the core database is aware of every other node in the core database. Hybrid HMA with local SSDs. So one of the big improvements, and I'm going to talk storage for a minute, is when I got there 2.5 years ago, we literally were making, and Criteo did this, we were literally making people manage their own storage. Local storage provisioner. If you ever hear that word, run, because it is a nightmare to configure. You have to be a geek to understand what it's doing. So the first feature request that, luckily enough, one of my best friends is the product manager for AKO at Aerospike. The first thing I did was call him up and I said, hey, Taylor, this thing here, that's got to go. And he's like, well, nobody wants to own it. I'm like, we don't need to own it. There's this product out there called OpenEBS that'll manage all the storage for you. It's open source, get support for it, and stop messing with storage. You point it to your storage on your node, and it will partition it for you. It will create the PVCs for you. When a node disappears, you can configure it for it to destroy the data or not destroy the data. You can do things like auto expanding volumes, all within this one little operator that I like to recommend sits next to the Aerospike Kubernetes operator. And it works. And it works really well. We have how many people here have heard of something called Snap? Snapchat? Anybody use it? Right? Snapchat runs on Aerospike, running AKO. They have 256, they have a 250 node Aerospike cluster for Christmas, New Year's Eve, when everybody's taking Snapchats. The core Snap feature of things disappearing after a certain amount of time, there's nothing special about that. That's what we call TTL. Any piece of data in Aerospike can be TTL'd. So you can say, hey, this piece of data has a TTL of 30 seconds. And then after 30 seconds, that piece of data disappears into the ether. So just keep that, like, all these things are being done within a Kubernetes infrastructure, all managed by, actually, all the Snap clusters. They have 30 clusters, but their nodes clusters are huge. They're in the 2 to 250 node size. It's managed by one person. Why? Because they don't have to mess with a lot of stuff. They deploy, they upgrade, all done from within their Kubernetes infrastructure. All right, Oscar, rock and roll here. Features, I talked a lot about this already. We use persistent volume claims. We are a good cloud native citizen. We use Kubernetes capabilities. We use RBAC, no special anything in our AKO. And right now, if you know the Kubernetes maturity model, we're about a 3.5. Our goal is to get to a 5, to be able to fully automate everything from within our operator. Cluster discovery, what does this mean? When you actually throw up a cluster and you upgrade an operator, the operator automatically finds the nodes, the Aerospike pods that made up that cluster. You don't have to think about it when you upgrade the operator. It does it for you. It says, hey, I'm about to be upgraded. Who's out there? What clusters do they belong to? What CRs do they have? Do they belong to? I upgrade the operator and I reattach to all those Aerospike pods that make up that cluster. So it's been very well thought out from a how do you manage stateful database. All right, Postgres, this is where they fail. You upgrade the operator, you don't know if you're going to get that replica back. You cross your fingers and you hope it's a replica. So if it goes down, you'll just re-replicate, your 6 terabytes of data, and it'll take you 3 days. And that is a fact in Postgres. Life cycles, we can be built into your CI/CD pipelines. Everybody here, if you're a dev or you're the ops side, are using CI/CD pipelines. Pick your CI/CD pipelines, right? Everyone has them. We can be built right into them. Just to give you an idea, I've talked a lot about Criteo. We have another customer, little customer in APAC. Anyone ever heard of Flipkart? They are the Amazon of India, right? Think about all the people that are in the United States, about 360 million. All the people that are in Europe, about 380 million people, right? They have 1.1 billion people shopping on their site, running Kubernetes with Aerospike. They said, okay, they were bought by Walmart recently in the US. We need to kind of get on the ball here. We're gonna go into the US market. We're gonna take on another 360 million. How do we do this so that we can keep building features and not bog down our operations? They built themselves an internal DBaaS. Developer comes in, says, I'm going to build a feature, deploy. I have a database. That database now goes through their CI/CD pipeline through testing, staging, and eventually into production. Developer is done. Data's been migrated up. Those databases disappear. They did that internally by themselves in under a year. That's crazy. They run about 400 clusters. So Criteo is still our biggest user when it comes to clusters. Built-in monitoring engine, we use Grafana, right? And Prometheus. We also are open telemetry capable. So if you're using an open telemetry monitoring environment, we can feed our metrics right into it for both the operator and all the clusters it's managing. Just sorry about the slide. Just to give you some ideas, this is how they deploy their database. No human interaction to deploy databases. So before I finish up, we we are pretty well advanced with AKO. Is everything in AKO? Not yet, or else my developers would be doing nothing, right? We talk about things called stretch clusters, where we can put one Aerospike cluster across many, many different regions, okay? That gets hard. When I say hard, when we talk about Kubernetes. Why? Because in order for an Aerospike cluster to stretch across multiple regions, you need to have the Kubernetes cluster stretch across different regions. And if anybody who's used Kubernetes knows that's federating clusters, and that ain't fun or easy. You have, or you go and you decide that you're going to do some kind of wacky ISTO cross mesh thing, which again is not easy. But I've been promised by the product manager that this is on our roadmap for first half of next year, where we will be able to do stretch clusters within Kubernetes. So it's getting there. And I throw up the summary slide just because in all that I've talked about in the last 30 minutes really fast, we don't break down these design principles. This is still why we're Aerospike. Questions? I've thrown a shit ton at. Use my French. Huh, Criteo. Questions? Well, wrong way, Oscar. So he told you this was going to be the hardest thing. Follow us on LinkedIn. My CRO, the last thing she told me today was, make sure they follow us on LinkedIn. And then if you're going to be in Stockholm, which Stockholm, early October is sweet. It is a beautiful place to be. Come join us. And then you can always look on our Aerospike event page for what's coming up. Thank you very much. Hugh, is he still here? Awesome presentation. I'm an aerospace engineer. That's the best talk about aircraft telemetry that I've heard in a long time. Thank you very much, guys. I hope I didn't bore you. I try not to. I can be a little long-winded sometimes, but I appreciate you coming. And you guys make me feel good because this room's always filled when I speak. So thank you very much. I appreciate you.